open interval a comma b such that f dash of c is equal to 0. The statement of Rolle's theorem is a function, a real valued function, that is y is equal to f of x, if is said to satisfy Rolle's theorem, it has to satisfy three conditions. The first condition is the function is continuous in closed interval a comma b, okay, and the given function is differentiable in open interval a comma b, and the third condition is f of a is equal to f of b, which means the functional value at a and the functional value at b both must be equal. If all the three conditions are satisfied, then there exists one element, that is c, and that c belongs to open interval a comma b, which means c lies between these two numbers such that this is the condition, f dash of c is equal to 0. Okay, so in your class you don't need to prove this theorem, but you have to apply this theorem. So Rolle's theorem, if we say that a function satisfies Rolle's theorem, it has to satisfy three conditions. The first condition is it is continuous in closed interval a comma b, and it is differentiable in open interval a comma b, and the third condition is f of a must be equal to f of b. Then there exists one element, that is c, that belongs to open interval a comma b such that f dash of c is equal to 0. This is the statement of Rolle's theorem. So next we do some problems using this theorem. Okay. So the next is verify Rolle's theorem. Verify Rolle's theorem for the following functions. Verify Rolle's theorem for the following function. So we have to verify the given function, it has to satisfy the Rolle's theorem or not. Okay, and in your examination point of view, these problems are very, very important for 3 marks. So important for 3 marks. Okay, so in that first problem, that is f of x is equal to what? X square plus 2, and a is equal to minus 2, b is equal to 2. So we have to verify interval, and it is differentiable in open interval, and f of a and f of b, and which means the functioning value at a and that is -2 and at b that is +2 both are equal. Hence all the three conditions of Rolle's theorem is verified. So therefore, what is the next meaning? What is the next statement? If all the conditions of Rolle's theorem is verified, then there exists one C. There exists one number, that is C, that belongs to what? Open interval a comma b, such that what is the condition? F dash of C is equal to 0. So using this condition, we have to find that value, and that must be belongs to this open interval. So here what is a? -2 comma 2. So we have to find one C value find out ಮಾಡಬೇಕು, and that C must be belongs to -2 comma 2. -2 ಮತ್ತೆ +2 ಒಳಗಡೆ ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ. We have to find that value. Okay, so hence all the conditions of Rolle's theorem is satisfied. So then consider in the next step, consider f of x. What is f of x? F of x is x square plus 2. So find differentiation of this function, that is what? F dash of x. So f dash of x means differentiation of x square. So this is of the form x power n. N into x power n minus 1. N means 2 into x power 2 minus 1 is 1. Therefore differentiation of x square is 2x plus what? Differentiation of 2. Since 2 is a constant, differentiation of any constant is equal to what? 0. So differentiation of 2 is equal to what? 0. Therefore f dash of x is equal to what? 2x. But what is the condition? F dash of c is equal to 0, right? But we want f dash of c. So here we have f dash of x. So replace x by c. That's it. F dash of c is equal to what? 2c. Okay. First take the given function, differentiate, then replace x by c. You will get f dash of c. So this is the condition for Rolle's theorem, right? So in the next step, so let f dash of c is equal to 0. This is the condition, right? So what is f dash of c? F dash of c is equal to what? 2c is equal to what? 0. So this implies 0. C is equal to 0. 2c is equal to 0 implies c is also equal to 0. And this 0 belongs to what? Open interval -2 comma 2, right? In the number line here we have 2, -1, -2, +1, +2. So we get c as 0, and the interval is what? -2 comma 2, and 0 belong between -2 comma 2, right? So the value of c is 0, and that 0 belongs to open interval -2 comma 2. Therefore, or hence Rolle's theorem is verified. Hence Rolle's theorem is verified. So this is very important problem for 3 marks. So I will explain once again. Given f of x is equal to x square plus 2. So we have to verify Rolle's theorem. We know that to say the statement of Rolle's theorem is it is continuous in closed interval, and it is differentiable in open interval, and f of a must be equal to f of b. If all the three conditions is satisfied, then there exists one c, such that, and that c belongs to what? Open interval -2 comma 2 or open interval a comma b, and the condition we have to use this condition, f dash of c is equal to 0. So further, since it is a polynomial, it is continuous and it is also differentiable. Find f of a and f of b. Here a is equal to -2, b is f of 2. We get same values. So all the three conditions of Rolle's theorem is satisfied. So in the next step, again consider the given function, find the differentiation, that is find f dash of x, but we want f dash of c. So replace x by c, then equate this f dash of c is equal to 0, because this is the condition for Rolle's theorem. So we have f dash of c as 2c. So which means 2c is equal to 0. It is nothing but c is 0. So that belongs to this interval. Hence Rolle's theorem is verified. Understand? So similarly, we do some more problems. Sorry, it is -4. Okay, we have to verify this function whether it satisfies the Rolle's theorem or not. So what is the first condition? So f of x is equal to what? X square plus 2x minus 8 is a what? This is also a polynomial function, right? Polynomial function. We know that every polynomial function is continuous. Therefore, it is continuous. Therefore, it is continuous in what? In closed interval. Here, what is the interval? -4, 2. Okay, it is. Since it is a polynomial, it is continuous in closed interval -4, 2. So the next condition, f of x is equal to x square plus 2x minus 8. Observe that clearly it is differentiable, right? So x square, differentiation of x square is 2x, differentiation of 2x is 2, and differentiation of 8 is 0. So therefore f of x is differentiable. The given function is differentiable in what? Open interval -4, 2. Okay, continuous in closed interval and differentiable in open interval. Then verify the third condition, that is what is f of x is equal to x square plus 2x minus 8. So we have to find f of a. So this is of the form a comma b, right? So value of a is -4, the value of b is 2. So first find f of -4. Okay, so replace x by -4. So it becomes -4 the whole square plus 2 into x means -4 minus 8. Now simplify this one. -4 the whole square is 4 square is 16. Plus into minus minus 2 4s are 8. Again here we have -8. So -8 and -8 become -16. So 16 -8 minus is -16. So it becomes 0. f of -4 is equal to what? 0. Similarly find. So write f of x as x square plus 2x minus 8. So we have to find f of b. What is the value of b? 2. So f of 2. Find f of 2. That is equal to, replace x by 2. So that is 2 square plus 2 into 2 minus 8. Right? So what is 2 square is 4 plus 2 2s are 4 minus 8. Okay. What is 4 plus 4 is 8. Here we have -8. 8 minus 8 is equal to 0. So therefore f of -4 is equal to what? f of 2. So all the three conditions are satisfied. So what is the next condition? Again consider the given function. That is f of x is equal to x square plus 2x minus 8. Right? So we have to find the differentiation. That is f dash of x. What is f dash of x? This is x square plus 2x. x square plus 2x. Differentiation of x square is what? 2x. Okay. Plus here 2 is a constant. We have x. Differentiation of x with respect to x is 1. So 2 into 1 is 2 minus differentiation of 8 is what? 0 because it is a constant. So f dash of x becomes what? 2x plus 2, right? But we want f dash of c. So f dash of c becomes, just replace x by c. 2c plus 2. So we have to find the value of c, right? So what is the condition for Rolle's theorem? F dash of c is equal to 0. So let consider f dash of c. Equate this f dash of c is equal to 0. What is f dash of c? F dash of c is 2c plus 2. Right? Is equal to what? 0. We have to find the value of c. Simplify this one. 2c is equal to -2. Or c is equal to -2 when this 2 comes to the denominator. 2 gets cancelled. C is equal to what? -1. And also that c belongs to what? C is equal to -1 and -1 belongs to the open interval. What is the interval here? -4, 2. So clearly -1 belongs interval, right? Right, because in the number line here we have 2, 1, 2, minus 1, minus 2, minus 3, minus 4. Here the interval is from minus 4 to plus 2. So minus 1 belongs to interval between these two numbers only. So C belongs to minus 4, 2. Hence Rolle's theorem verified. Hence the Rolle's theorem is verified. Understand? So the next problem. So the next problem is the third one. F of x is equal to x square minus 1 for the interval 1, 2. So we have to verify the function that is x square minus 1 for the interval 1, 2. We have to check whether this function is applicable for Rolle's theorem or it is satisfy Rolle's theorem or not. Okay. The first condition, f of x is equal to what? X square minus 1. It is what? It is a polynomial function, right? We know that every polynomial is continuous. Therefore, it is continuous. Therefore, it is continuous in what? Closed interval 1, 2. Okay. What is the second condition? Clearly, it is differentiable, right? Differentiation of x square is 2x. So, f of x is equal to x square minus 1 is differentiable. In what? Open interval 1, 2. So, for continuous you must write closed interval, and for differentiable you have to write the open interval. So, when come to the third condition, that is f of a must be equal to f of b. What is the value of a? A is 1, b is 2. So, consider f of x again. What is f of x? X square minus 1, right? So, find f of a means 1. What is the value of f of 1? Replace x by 1, that is 1 square minus 1. So, what is 1 square? 1 minus 1, that is equal to 0. This is what? F of 1. Similarly, find f of b. First write f of x, that is x square minus 1. So, what is the value of b here? b is 2. So, find f of 2, that is 2 square minus 1. Okay. So, what is 2 square? 4 minus 1. So, 4 minus 1 is 3. F of 2 is 3, but f of 1 is 0. So, therefore, f of 1 not equal to f of 2, right? F of 1 is 0, f of 2 is 3. F of 1 not equal to f of 2. So, first condition, second condition satisfied, but the third condition does not satisfy. Therefore, Rolle's theorem is not applicable. Rolle's theorem is not applicable. If one condition out of these three conditions, any one condition does not satisfied by the given function, then Rolle's theorem is not applicable. Okay. So, the given function does not satisfy Rolle's theorem. Understand? I hope all of you understand, and this is very important for 3 marks. The continuation I will discuss in my next session. Thank you.